Okay, so today's plan is to be able to graph a linear graph. Now, this is something that should be straightforward and pretty easy for you to do. This is something you've been doing, well, believe it or not, since middle school. Probably about 7th grade is when you started to learn about this. However, they've gotten to a point where they don't have to be in one certain form. I don't want you to be limited to simply being able to graph when it's in the y equals mx plus b form, but expand it to any kind of linear graph. Now, the first question that I would ask you to think about is, how do you know it's a line? How do you know when it's a parabola, or how do you know when it's a line? My hope is that in your mind, you're already saying a line means that the x is to the first power and the y is to the first power. We have to be a little careful about that, and we'll get into those kinds of graphs as well, but there are other types of graphs that actually do have where x and y are to the first power. So there is another distinction, but we'll get to that when we start studying hyperbolas. But for today, that's basically all you need to know to graph a linear graph and being able to recognize that it is in fact going to give you a line. Now, most of you, when you learned this, you learned y equals mx plus b. And so you learned, I hope anyway, that m represents slope, and the b represents the y-intercept. How is that the same as parabolas or quadratics? How is that the same? Remember when I asked you before to find the y-intercept when you were doing this with quadratics, the same steps are going to be used. You'll notice that I have find the y-intercept, find the x-intercept. You'll notice there isn't a turning point because with a line there isn't a turning point. But the approach is the same, that we're going to find the intercepts and then we're going to sketch it. So what do we know about the y-intercept? The y-intercept is when x equals 0. That has not changed. You'll notice that every time I teach a graph, I'm not going to teach you new steps. It's going to be the same steps. X-intercept, y-intercept, graph it. So in the case of the y-intercept, that's when x equals 0. It's usually the constant. Isn't that the same as you found with quadratics? That when you look at this equation, y equals mx plus b, that number that's by itself without an x term, that's the y-intercept. It's the same for lines as it is quadratics. No coincidence there. Okay, how about the x-intercept? The x-intercept is when y equals 0. And that, of course, that usually requires some sort of solving. Not much when we're talking about lines, but it does. And then we, of course, sketch it. As a quick side note, other graphs that we should know, when you see x equals a number, x equals 5, x equals 10, x equals -3, those graphs will always go up and down. And y equals a number will always go left to right. Okay? Good. Let's do some examples now. Y equals 2x plus 6. First thing I want you to see, all right, we have the y-intercept. I want your setup to be very similar. Y-intercept, 6. X-intercept, that's when it equals 0, or the y part is 0. So now we solve it. We subtract 6, and you divide by 2. And I already have the 2 parts. So this is how simple it is. X, -3, y is 6. Boom, you got your line. Next, y equals -x. What's the y-intercept? What's the constant over here? 0. Excellent. And the x, put 0 in for y and solve. That means I have to divide by -1. 0 divided by anything is 0. Oh, so what? I only have 1 point. I don't have 2 points. What do you know about negative slopes? Which direction do they go? Do they go up when you're reading them left to right? Do they go up to the right, or do they go down? They go down. That's your negative slope, and that's all it is. Now, in the past, when you would look at the examples like you see here, okay, so in the past, these are the ones that you had trouble with. But if you notice, actually, with this method, isn't any different than what you've been doing. So the first step, it's not as simple as what we've done in the other two with you just finding a constant, because it's not the same. You'll notice y is not alone in this example. So to find the y-intercept, what is it? It's when x is 0. So if you put 0 in for x, this term is now gone. And I have, literally, you can cover it up with your hand and then just solve for y equals 8. It's 2. I actually find these to be easier than the other ones. Your x-intercept in the same way is when y is 0. So now we plug 0 in for y, and it goes away. So I have 2x equals 8. And again, you can solve that in your head. So x is 4, y is 2, boom, and you've got your graph. Easy as that. Last example here. Y-intercept, that's when x is 0, gone. Y equals 4. X-intercept, that is when y is 0, so that's gone. 3x equals 4. Oh, that's not pretty. But remember, we're just sketching. We're just getting an idea. We've got 4/3 here. We've got 4 here. Boom. And we are done. And those are 4 graphs, linear graphs. If I just move this real quick, you can see. Beautiful. We have all those answers perfectly. Great. All right. Well, that's the end of this video. Hopefully it gave you enough of a background on how to graph lines.